I work for an organization called CCAFS, the Climate Change, Agriculture, and Food Security Research Program, and am based at the University of Vermont. And our work spans 15 different centers of the CGIAR, where we're focused on improving food security first and foremost, but then making sure that we can do so in ways that reduce the impact of agriculture on the climate. And I lead the low emissions development program across those 15 centers. And one of the biggest challenges of the last 5 years in particular has been the debate around soil carbon, and soil carbon particularly as a silver bullet way of approaching climate change and reducing the impacts of agriculture. So I thought today it would be really useful to review the big debate and try to move us forward by showing some of the really exciting initiatives that are happening and how I think we can safely move forward despite some of the issues. I also just want to welcome everybody to the start of a new semester and this brave new world of online gunned teas, which are now exchanges because we can't drink our tea anymore. But hopefully you all have something delicious to eat or drink in front of you. So to begin. We think that about 25 to 70% of the soil carbon stock in agricultural land has been lost since cultivation started, which we think is about 12,000 years ago, although most of that has been lost in the last 150 years with the expansion of agriculture and population. And you can see in this wonderful map from John Sanderman, in the red areas, areas of extremely high loss, for example, in Europe, and areas of medium loss in the yellows, and then areas of some gain in the blues and greens. And you can see that we have predominantly yellow and red. So indeed, agriculture is the driver, the major driver of soil carbon loss, whether that is due to the conversion of native vegetation or the use of peatlands, of organic soils in peatlands and the drainage of those, or most commonly just the disturbance of soil in the process of planting crops in particular. And as a result, we have now, by most estimates, more than half of our land being moderately or severely degraded. And the major degradation, of course, is soil loss, but there are other aspects of degradation which might be, for example, salinization. So why do we care about soil carbon in the soil? Forget about climate, just in the soil, of course, because it provides nutrients, it helps water storage, it provides soil structure as well. And all of those things have multiple benefits and interact with each other and are essential for crop productivity. So we have a real issue around food security in the developing countries where I'm working primarily and most interested about, but we also, of course, have a concern about soil carbon for the climate. And in addition to worrying about building soil, we're also worried about losing soil carbon that we already have. So we know that soil carbon is the largest terrestrial pool of carbon, and we think it's about 1,500 gigatons of soil carbon, if you count it down to 100 centimeters of depth. And you can see in the map in the right, the areas of high soil carbon, and those correspond mostly to areas where we still have a lot of forest in particular, or grassland. And on the left, you can see the countries where we have most of that soil carbon, with Russia, Canada, the US, China, Brazil being the top 5. I should say that about a third of that potential exists in peatlands. So peatlands are a real priority for conserving soil carbon. So all of this has come to a head in the last 5 years. In 2015, the UNFCCC Paris Agreement was established, and as part of that, with the French government hosting the Paris Agreement, the French Agricultural Ministry wanted to establish an action that would be significant for implementing the Paris Agreement. And so they came up with this notion that is now recognized as flawed, but this notion that sequestering carbon in the soils would help both food security and potentially, and this is the flaw, offset all global emissions. And I won't go into all the details of why that is flawed, but this created enough huge attention that suddenly, really interestingly, we shifted into this world where soil carbon became the major solution. It wasn't coincidental that around that same time in 2015, there was a lot of discussion about the need for what's called negative emissions, or increasing carbon sinks as opposed to just reducing emissions. And recognizing that in order to meet the 2-degree or hopefully 1.5 degree centigrade target by 2100, that we needed to achieve what is known as net zero emissions by 2050. By estimates in 2017, if you look at this little figure on the left, you can see, and this was in 2017, mind you, that by 2020 we were supposed to be peaking in emissions, and that by 2050 we achieve net zero, and then in the future after that we maintain negative emissions. But essentially the strategy was to increase negative emissions, and so the soil carbon narrative was really well aligned with that. And you can see in this carbon clock that I clicked on last night at 9 o'clock in the evening that we have about 7 years and 3 months and 21 days to achieve our climate targets. And so clearly negative emissions are going to be necessary. Meanwhile, the 2015 fever around soil carbon also created a host of estimates of what the real soil carbon potential is. And we find that it's about 2 to 5 gigatons of CO2 equivalents per year in agriculture specifically. And that range really represents different ways in which people scope agriculture, whether it includes grazing lands, for example, or not. We have to temper that estimate, though, with an understanding of what's economically feasible and what can be actually adopted, for example, at low costs of about $10, we could say, per ton of CO2 equivalents. And that number is a bit lower, so about 1 gigaton of CO2 equivalents per year. And to put that into perspective, that's about 25% of our current agricultural emissions. So we could offset a significant amount of current agricultural emissions. The problem is that, of course, sequestration rates vary, and the area that we can actually address will also vary. And you can see on the right a very nice figure from Keith Postian that shows on the x-axis the rate of reduction that soil carbon can achieve, and on the y-axis the area that is potentially addressed with that measure. And you can see then in the upper left that addressing especially grazing lands, croplands, and biochar, although biochar is controversial, would achieve low rates but at high areas, and so it has a very high potential. In contrast to the lower right, where you can see that we can have very high rates by addressing, for example, peat soils, but it would be in smaller areas. Of course, associated with all of this are very high uncertainties associated with the actual land areas involved. Most of this is based on maps, not even dealing with topography, uncertainties around soil depth in many places, the soil processes themselves, especially in the subsoil, and landscape processes like erosion. Right? So those potentials are really just right now theory. Also kicked off with the 2015 fever was a lot of attention to particular practices that are promising for soil carbon. And we have decades of experience with most of these practices. We know that they increase inputs of soil carbon. What we don't know as well is whether they store soil carbon, especially for long periods. So in the upper left, you can see a cowpea and maize intercropping system in Malawi, very much liked by farmers. And you can see in the background also some trees, some agroforestry, another major practice for increasing soil carbon. On the right, you can see burning and stopping, of course, reducing burning in agricultural areas, whether for clearing land or as a means of clearing crop residues, is essential both for climate, for CO2 emissions, but also for reducing black carbon, which is a major influence on the climate. You can see also the composting, but which has constraints associated with the labor inputs required, and also where you get the compost materials. Are you just transferring them from another site, and then manure on the right? So these are the major technologies that have really received a lot of attention in the last 5 years, and increasing funding as well, I should say. So with all of this hullabaloo, we've seen some backlash, and I think it's been really healthy. Last year, the 4 per mil initiative, which has a science committee, wrote an article summarizing the arguments against the 4 per mil initiative, and essentially against why high soil carbon, the highest soil carbon potential is not necessarily achievable, and started to address some of the ways in which those issues could be overcome. So some of them are quite tough, like biophysical limits in terms of the biomass available to put into the soil, or phosphorus limits for increasing productivity, socioeconomic barriers to adoption. But I think what's healthy is that, people are giving the issue attention, and we're starting to think these things through. So we find ourselves with one of these big hairy problems, or grand challenges, where we have to ask, what is the real potential for soil carbon sequestration for climate change mitigation? And what can we do about it? And I really like something that Debbie Basio has said, which is that it's an opportunity that should not be dismissed, but not exaggerated, right? So we shouldn't just throw it out because we don't think it's possible. And I also think we need to pay attention to this very live debate, which is pushing our knowledge forward. But the question is, do we just get stuck in that debate and not act, or do we move forward? And with the urgency of climate change, I don't think we can wait for the science. And so with so many of these complex problems, we have to work in a very adaptive manner, iteratively, and think through with initiatives what's possible. So it's time to move forward from a discussion of these potentials towards doing and creating a vision. So the first way to think about this is to start with, what have the issues been? And there are 3 major issues if we think about trying to achieve large scale change in soil carbon. The first is, there's no guarantee that what you add will stay in the soil. As I mentioned, agriculture is a driver of soil loss. We need constant organic matter inputs. Soil carbon is often increasing very slowly in the soil. You might not see changes until 5 years. And also farmers just economically may not hit an equilibrium point until, I heard yesterday in a seminar that we had 12 to 20 years. And at the same time, you can have really quick losses. And perhaps the most important point for agriculture is that once you put the soil carbon in, there's no guarantee that it will stay there, because soil will, if it's cultivated again, it can be lost, but also soil has a finite amount of soil carbon that it can achieve. The second major issue is that you can't tell necessarily how much has been stored. We have really high variability in soil carbon over both space and depth, especially at farm and project scales. The activity data, what we call activity data, in other words, what farmers' practices are and how many hectares they're practicing that over, our indicators don't relate very well to how much soil carbon is actually being stored. And our data are just generally poor about those activities. And as I mentioned, it can take some time before you can even see any changes. And finally, large scale and sustained change is going to be tough because of biophysical limits. In arid areas, you just don't have enough water necessarily to increase the biomass inputs. And we have nutrient inputs, energy inputs, and often we have to bring in other inputs from other places. We also have trade-offs with greenhouse gases. For instance, nitrogen fertilizer will yield nitrous oxide. So if you need nitrogen fertilizer to increase your productivity, to increase your organic matter inputs, you're going to have to account not only for the soil carbon that you store, but the increase in nitrogen, in nitrous oxide, which does tend to be larger than the amount of carbon stored, especially over long periods. We have socioeconomic barriers in the sense that we don't have a carbon price yet that is enough of an incentive to drive behavior. We need incentives not only one time, but ongoing, because farmers need to continuously provide inputs to their soil. Policy change tends to be very slow. There are investment risks. Land tenure is a real issue in many places. And then all of these solutions need to be specific to farmers' contexts. So despite all of these issues, we do see some entry points. At the government level and the level of the Paris Agreement, we have countries with nationally determined contributions where we have at least 27 of about 200 countries that have now specifically referred to soil carbon and set examples of how to have targets for mitigation. We have 11 countries that have targets for soil carbon. This is a hugely political instrument, and specifying soil carbon as opposed to just targets in the agriculture sector raises other issues that I can discuss. But I think that the momentum around increasing transparency and ambition in soil carbon in the NDCs has already started. We have some really cool examples of government initiatives. In Australia, the Carbon Farming Initiative has already 50 registered farmers, so small. And one farmer, I think, has already received payment in the last year or so. But it's a methodology that has been proving now to work. And in California, we have the Healthy Soils Program that I'll say a bit more about, that is providing actual market incentives to farmers. We have private sector initiatives. Indigo, which is based in Boston, has something called the Teraton Initiative that I'll also describe in a moment, where they're seeking to achieve 1 trillion tons of carbon sequestration, paying farmers somewhere between $12 and $24 per hectare. We have corporations, everybody from Danone, Mars, Bayer, Coca-Cola, Fonterra, Diageo, and Olam are all engaged in trying to improve soil carbon in different ways. And we have, and I love this, we have some really interesting entrepreneurs either taking urban waste and converting it to compost, or trying to develop new kinds of soil fertilizer amendments that include, for example, enzymes, and I'll discuss COFAR in a moment. And finally, the sleepy carbon market does have some projects, very few again, and if the Paris Agreement Article 6 succeeds in creating a viable carbon market, we may see more of these. But the first and oldest of these is the Kenya Agricultural Carbon Market, which I'll also discuss in a moment, with about 37,000 smallholders and about 1 million tons of carbon that have already been verified and payments made. And this started more than 10 years ago. And then the major carbon market methodology standard known as Verra has also just indicated in their seminar yesterday that they now have 12 agricultural carbon soils in development or in their pipeline, or developed or in their pipeline. So I think all of these initiatives are super exciting. They're small scale, but they do provide entry points. So just to highlight some of these in a bit more depth, I mentioned the nationally determined contributions. If you look at the map on the top left, you'll see that this shows the soil carbon potential. In blue, you can see croplands. In blue, you can see grazing lands, and in green, you can see croplands. And you can see that we have major potentials, for example, in the US, Brazil, India, and various parts of many other countries as well, of course. But then if you look at the map on the right, where you can see where soil carbon was specified in the NDCs, we have only a few countries, and they're not necessarily the most important countries for actual soil carbon sequestration. We do know quite a bit about the barriers. This was a major study done by CIRCASA, a European Union initiative where major stakeholder consultation was done globally with 1,500 different stakeholders. And we know that the major incentives are that people want to see rewards for soil carbon sequestration. They want to see farm extension services. You can see in the green and blue colors as the major reasons or major barriers, that soil carbon is not a political priority, and that people just aren't convinced by the productivity and economic benefits. And most of the other barriers all relate to different kinds of benefits at farm scale or information. So really, how do we get these benefits and finance to farmers? So I mentioned that California has a new soil health, and I'm just going to run through these very quickly, a new soil health market that they've created where they're paying farmers for specific practices and awarding soil carbon credits. And they do this on a practice basis. So if a farmer can demonstrate that they're using a particular practice, they get these rewards. The World Bank has very strong commitments to climate change action in agriculture, what they call climate smart agriculture, with soils being part of this. In the last 3-4 years or so, they've almost doubled their investment portfolio, and they've made a commitment to increase that to 2/3 of their agricultural portfolio by 2025. And soil carbon is a component of that. They plan to address at least 20 countries and 10 million farmers. So we have one of the global multilateral development banks, very invested in seeing these outcomes. And I mentioned the Kenya Agricultural Project that was initiated by the World Bank. And then they've also recently, in the, I don't remember how many years ago, it was 2 years or 3 years ago, started a national Kenya climate smart agriculture project with investment of 250 million. So we can see more and more of these projects likely to come online. I mentioned that Verra is also working hard on improving soil carbon accounting methodologies in their program. They have currently, I believe they're working with Indigo, expert agricultural land management working group working just on soil carbon and developing new accounting methodologies. And they're trying to reduce the cost of measuring soil carbon, which has been one of the main barriers, by improving technology advances like the use of remote sensing and modeling. They also want to simplify some of their own VCS rules to make it easier for agricultural applicants to apply. Indigo, I mentioned again, out of Boston, is a private company that's trying to really revolutionize some of the technologies available. They're doing what they call a kind of an end-to-end approach to soil carbon, where growers can enroll in the carbon offset program, and then Indigo supports them with practices. They help to quantify the soil carbon that they have, and then Indigo sells the carbon offset with the value of that being transferred to the farmers. Indigo is also trying to improve the research behind the practices that improve soil carbon by working with growers and universities, especially on tillage. And they have right now, I think, over 3,000 samples that they've collected, and they're trying to just identify different protocols for different aspects of the soil. And this is more broadly around soil health, which is another topic that we can come back to, because of course farmers are interested in more attributes than just soil carbon. The FAO, the UN Food and Agriculture Organization, has something that they're just launching now called the RECSOIL program. And this is quite similar to the Indigo program in the sense that they're creating agreements with farmers that will enable them to access technical support and financial incentives. And then one of my favorites, a woman-led group in Kenya is producing different kinds of soil fertilizer that include either residues, so they're improving not just the NPK, but providing organic matter in the fertilizer or enzymes that will help to promote that. You can see on the right the comparison of one of their products. So in the bottom picture, you can see on the left where the root mass is increased because they think of the use of their product. So to bring all of this together, how do we take these growing initiatives and, as I said, try to move with the debate, keeping the debate alive, but beyond the debate stymieing action? And I think it requires, and this was the subject of a very nice article by Sonia Vermeulen and others, clear collective action on soil. So how can we create a collective vision and awareness for what kind of action is necessary, and having that led by champion actors? And this presentation and a lot of the work that CCAFS is doing is trying to foster that vision and awareness with a healthy dose of that debate and knowledge of the issues that constrain us. A second major area where we need collective action then is helping to build that investment case through pilot funding of commercially viable soil carbon initiatives. And we can see that happening with initiatives such as the World Bank and the California Healthy Soils Initiative. And we just need to keep identifying and working with what farmers' incentives are and supporting those through both public and private sector action. Through all of this, it's really essential that we remember that there are going to be negative, unexpected impacts. So this is just an example with fertilizer, which impacts soil carbon. But if you have too little fertilizer, of course, you have trade-offs and SDGs related to food production that affect poverty, hunger, and good health. If you have too much fertilizer, you have issues with clean water and climate, for example. So we really want to hit that sweet spot, which I think also requires collective action around setting standards for optimal outcomes and monitoring on a regular basis. So just to conclude, we still have a grand challenge, but the whole point is that we can work on it. And action is going to be needed on multiple fronts. We can't just treat this as a technical implementation problem and just talk about the practices that we know can enhance soil carbon in some places, but not others. So how can we continue to set ambitious targets and work towards these large-scale systemic changes that we're going to need in both the public and private sectors, especially incentives for farmers, advisory services, novel technical options, and continue to build will, right? We know that this is going to take time, but also to test what the priorities are and the strategies are with these iterative, more adaptive approaches, where we can make sure that we're optimizing our impacts and our trade-offs. And all of this, I'm hoping that will improve our understanding of mitigation potentials and what can actually be done for implementation success. And we should be doing that with long-term monitoring of networks of sites on actual farmers' fields. So thank you very much. And I look forward to your questions and stimulating more debate, but hopefully also more action.
Thank you very much, Lini. And I think the one piece that's really missing in these virtual seminars is the round of applause for Lini. But thank you very much for such a great conversation. And we have a lot of questions already flowing in the Q&A box, but please, to all the participants out there, put your questions in the Q&A box and I will help, I will bring them to Lini's attention. I'm gonna take the opportunity to ask the first question. And I think that pertains to one of the main issues that the barriers, I guess, that you mentioned with carbon sequestration is soil carbon sequestration, is that there's no guarantee that carbon added will stay there. And answering those questions really relies on long-term scientific experiments, but time is maybe the one ingredient that we don't have as we try and tackle these challenges. And so I'm wondering if you can think of ways that we can get around that need for long-term experiments and get answers to these scientific questions in shorter timescales or even immediately.
Yeah, thank you. It's a great question. Of course, there's a substitution of space for time. And so being able to get many more samples from many more places is essential. And what's happening right now is people are using AI to do machine learning estimates of soil carbon based on reduced samples. So I think the goal is, let's measure high quality. Well, first of all, let's take advantage of our long-term experimental sites that we have everywhere. Let's focus on where we can get high quality measurements and do that on a regular basis with reasonable cost. But then let's use the tools and the methodologies that we do have available. And we have some great models out there to better understand what the long-term consequences might be. And as I said before, with any of these complex problems where we have high uncertainty, we just have to keep monitoring as well. Thanks.
Great, thank you. I'm gonna ask this question from Taylor Ricketts. He says, Lini, are the uncertainties with agricultural soil carbon bigger or smaller than those associated with forest carbon, with all the science and policy attention that has gotten?
Thank you, Taylor. I don't know enough about the forest carbon figures, but because we have the added complexity of farmer management or people being involved with varieties of practices and the interactions, with soil at the farm level, involving, crops, livestock, and then just human behavioral change over that small landscape, we just have a lot more variability. And so, any statistical representation of that inherently involves more uncertainty.
Fantastic. I'm going to read this question from Alyssa White, but it's a question that several different participants have asked about. Alyssa says, Lini, can you talk about additionality, especially in regards to some of the carbon trading programs that you mentioned? If farmers' carbon credits are being used for offsets, are they actually contributing to net sinks of carbon? This seems to be true in the California program and Indigo.
Yeah, thank you, Alyssa. Additionality is really difficult to demonstrate in a lot of agriculture. And after going around in circles on this, my own conclusion is that we need to drop it. And I think a number of other people, even in the carbon credit market area, would tend to agree. But the problem is, of course, you don't want to pay people, twice for the same carbon credit. And so, Indigo and Nori and Verra are all dealing with, how to register credits and assure that credits are not double counted. Again, in this talk yesterday, Nori confessed that, while they can register people for soil carbon credits, there's no guarantee that somebody else will then buy their soil carbon credits after Nori is done with them, for example. So it remains an accountability issue within the carbon market area. But I think for action that we just, because additionality is just too complicated to be able to demonstrate in those cases, that we just need to focus on practices that will help generate soil carbon, and not get too fussy about additionality issues.
Thank you. This is a good one. Donna Rizzo asks, do groups like Indigo offer funding grants, to universities or research groups to work on carbon sequestration activities and best management practices?
Donna, I can put you in touch with them. I've wondered the same thing, how they're getting collaboration with their partners. They're for profit, and I know that they operate a very lean business, so I'm not sure. But I also know that they get some grants as well. So if you'd like, I can put you in touch with them.
We have another question from Deb Nair. Do you think farmers are receiving a fair compensation for changes in practices that increase carbon sequestration? Are some programs addressing farmer compensation better than others?
Yeah, thank you, Deb. Great question. So, for the conventional wisdom in low emissions development or mitigation in agriculture is that no practice should be promoted unless it's also supporting farmers in their own goals. Right? It just doesn't make sense in agriculture to ask a farmer to do something that doesn't support their own goals. And in this case, the assumption is that improved soil health also improves crop productivity. We know, though, that also soil health is an asset that really serves, that has some long-term benefits that farmers might not see in the short term. And so somehow that balance between trying to enhance soil carbon for the long term and enabling farmers to reach that 3 to 5 year point, right? So they have to be compensated somehow for that initial 3 to 5 year period where they can get to the point where they can benefit from the soil carbon that they've invested in. So I think that it's not a matter of paying farmers so that it's not a matter of the fairness of the carbon credit. It's more a matter of, can the incentives be sufficient to support farmers through that transition period? And it will be fair if the farmer adopts it. So the test is really upon the farmers more than anything else. There is one exception to that, which is in the US, cropland set-asides are a policy, and I believe in Europe as well. And, farmers are being paid to set aside land, and that's seen as a soil carbon conservation measure as well. And, I think, again, it's a voluntary measure. And so if farmers feel that that's to their financial advantage, then, it feels to me that that's the best test of fairness.
Thank you. That seems like a really practical test. Will they accept this? And they can be the best judge of if it's fair to them or not. The next question is from Ian Deschmuck, who says, do you have a sense of what carbon price is sufficient incentive to, say, small landholders in Africa versus large landholders in developed countries?
Oh, great question. So I usually deal with numbers like $10 per ton of carbon as sufficient in developing countries. I wouldn't go higher than that. We talk often about $50 to $100 per ton of carbon in developed country settings. And there's some that really feel it's likely that we'll go up to 100 tons of carbon in, for example, the US, Europe, or North America, I should say, and Europe and Australia. That being said, any carbon price, we've done an analysis with IASA, any carbon price will disadvantage farmers who are inefficient in producing carbon, which tends to be most farmers in developing countries. And so, you know, while we might want to create a low carbon price, so let me back up for a second too. Well, carbon prices reflect for the most part what it costs to get a farmer to adopt. So it might be the farmer of a subsidy for fertilizer, for example, in Malawi. That's a good thing, but it also could disadvantage farmers if they're actually then paid for the carbon, which is a different way of thinking about the carbon price, because farmers will get paid for carbon if their system is more efficient overall. And what we found with the IASA analysis is that paying for carbon will actually disadvantage farmers, especially in developing countries and especially in sub-Saharan Africa, who tend to have poorly efficient systems.
Thank you for that as well. We have a kind of a multi-part question from Jeremy Matt, but it all comes down to suitability of different soil types for taking up carbon. He asks, very interesting talk about the soils having a finite storage capacity. It makes sense that in a sandy desert, the soils aren't going to hold much carbon. But wouldn't the soils in areas where carbon loss is high have a higher potential to store and retain carbon? Or can loss of carbon reduce a soil's ability to retain carbon in the future?
Not sure I caught all parts of those, and let's see, I think I have it in front of me though. Makes sense. Wooden soils in areas where soil carbon loss is high have a higher potential to store and retain carbon. So yes and no. For example, if we had a histosol, which is the highest amount of carbon that you can have in a soil, and it's drained, the carbon there is lost. And we could redrain it and we stop the loss of that soil carbon, but we're not regaining it, at least not in the short term. In areas where we have had, let's say in a cool region, in a temperate region, I'm thinking with extremely fertile, relatively young soils, and you've farmed that, yes, the soil inherently has a higher capacity to regain organic carbon, as long as you have the inputs. So you can't just think about the soil qualities. You also, of course, have to think about the management of those soil carbons. So yes, we should be targeting soil carbon in areas that have high carbon, I should say potentials, not just high carbon loss rates, because we have to think about what the primary productivity potential is, and the and the management possibilities, and also what kind of soil it is. Thanks.
Thank you. I really enjoyed getting down into the weeds about soil types and things like that. Those are important questions to be
very much so
thinking about in this context. There are a couple of questions too that are related to the challenges of measuring rates. So it's one thing to just measure soil carbon contents at one time point, but how do we measure loss, especially when we're thinking about, at the current day, how much carbon of soils lost in the past, and then measuring that into the future when we're thinking about gaining carbon. So what's maybe the appropriate time scale to be doing that monitoring on? How many times do we need to be measuring? What are some good and maybe cheap monitoring frameworks that we can use to roll out at large areas and large time scales?
Yeah. So generally, because of the slow rate of gain, the time scale for measuring soil carbon change is generally seen to be around 5 years. That's a good average. It can be faster if it's a high input of soil carbon, right? But for most agricultural systems, 5 years seems to be about right. I've heard of even 7 to 8 years before you can detect a change, because the percent of increase, because soil carbon is very low to begin with in the soil, and you're only increasing soil carbon marginally, to detect that change does take time. And also over time, we often have an initial decrease in soil carbon and then a building up. So you want to be able to capture change over a certain number of years. You know, the frameworks for measuring soil carbon, I think other people probably on this call are best placed. And I was really hoping we could, you know, draw on the wisdom of folks like Deb Nair and others. And I'm sorry, I can't really see all the participants, but just the people who've asked questions. But they're better placed to talk about the systems, you know, for measuring. What I've seen is people suggesting, again, that we combine these long-term experimental site data with our models, for example, with either DNDC or with DACENT in the US, and we combine that with good remote sensing, and that we're continuously updating our models and creating more integrated platforms that allow us to, you know, be repeatedly looking at these specific points, repeatedly improving the models, and hopefully being able to have nice feedback and learning involved with that.
Thank you. I'd just like to remind everyone we still have plenty of time for more questions. So if you want to just keep those questions coming. I have another question though, and it's kind of more open-ended, but when we think about, you know, especially that when we think about that we're rolling out the science of soil carbon sequestration at the same time that we're really applying that science and trying out new management techniques. And there's always the risk that they won't work, right? That we try to do something that benefits soil carbon, but it doesn't work. And maybe you get these other soil health benefits aside, but how do we guard against widespread rollout of practices that are kind of a net negative, both in terms of carbon and in terms of soil health?
Yeah. So I think the big risk is in crediting and false crediting. I also worry that there's going to be a backlash. We've already seen a bit of a backlash, but more of a backlash when people realize that soil carbon is not the answer to mitigation, especially in developing countries and tropical soils, and especially in arid tropical soils. So, you know, I think it goes back to creating some safeguards around crediting for poor farmers, smallholder farmers. I also am concerned that smallholder farmers, you know, will go into some of these schemes and then they'll be somehow seen as the enemy, or not the enemy, but, you know, the bad guy when, you know, they cultivate their soil in a way that then releases soil carbon, even though they need to do that for their livelihood. So, you know, it goes back to creating, it goes back to monitoring basically and creating safeguards and being very cautious about credits. I think we need a lot of rigor in any kind of crediting scheme. So my basic message would be go for it in terms of practices and supporting practices, because we know that those practices at least will support climate change adaptation and soil health, right? But to be much more cautious about assuming that there will be a mitigation effect, and then improving our understanding of the mitigation effect over time, probably focusing on the regions and types of farming systems where we think this is most viable.
Great. We have another question from Kyle Dittmer, who says, with so many farmers currently under severe economic strain in a COVID-19 world, is there an opportunity/need to link ongoing public or private disaster relief funds with technical assistance for adoption of practices to sequester carbon?
Yeah, thank you, Kyle. You should know about this from CCAFS work on COVID. So yes, in fact, you know, we see a lot of initiatives right now that are seeking to help build back better, and some finance initiatives. The UK Pact has a call right now out about trying to support green finance to support people to build back better. So hopefully the current experience is going to, you know, alert people to recovery mechanisms that could integrate more green finance, right? Including some standards for what green means, that might include, in this case, as you're suggesting, Kyle, you know, carbon sequestration practices. So, you know, I think it's a terrific idea, and people are definitely working towards that. There was also, I think, I don't remember how many months ago, an agricultural ministerial meeting where they were talking about this. So it's very much on the minds of quite a few funders, as well as those managing agriculture. Great question.
So we have Taylor wanting to dig in a little bit about the idea of additionality. So he asks, I'm amazed by the idea of giving up additionality. Can you talk more about how widespread that position is? It seems like a quick route to backlash, especially if there are tradable credits.
Yeah. So Taylor, indeed, my position earlier about supporting practices and being very cautious about credits answers that question. You know, there is, I don't know how widespread it is, but I have been in meetings where people concerned about agriculture and carbon credits in the US have talked about just the difficulty of additionality and whether we should address it or not. So yes, carbon credits need to be demonstrably additional, but assuming that carbon actions to support carbon in the soil should happen regardless of whether they are additional or not. And my fear is that if we only support farmers for additionality, that will also potentially damage the effort to just enhance the soil health. So there are multiple aspects of the additionality argument.
I have a question that's it is kind of related to additionality. So soils aren't bottomless pits for carbon, pun intended, I guess. And when we think about offering financial incentives for storing carbon, does it concern you at all about what happens when farmers have achieved some carbon storage, but they've really saturated the soils in terms of soil carbon? Does that risk some kind of financial instability or maybe even loss of that carbon should payments stop?
Yeah. Now, it's one of my biggest concerns with how people are thinking about soil carbon, because the argument is often made, as I said in the talk, that soil carbon provides the negative emissions, but those are finite, right? It only provides negative emissions up to a point. And farmers, in order to maintain even saturation, so saturation is a complicated concept, and we can get into that a little bit. And again, others are better placed to discuss that than me. But in order to maintain their soil carbon, farmers need a constant input and a constant reduction of their output, right? Or they need to somehow manage the input-output flow so that they're maintaining a carbon stock either at saturation or hopefully still growing it. And the practices themselves, by the way, can change that equilibrium point. So you could reach saturation, change your practice, and potentially in some soils have a higher equilibrium point. That's why it's complicated. And again, I'm not the expert here, but my main concern is that when people think about soil carbon sequestration, they don't think about a 20 or 50-year time limit to that. And so they're not thinking that agricultural emissions, which we haven't talked about very much at all, are still growing every year, additional increments, right? And the soil carbon, yes, we've in the short term achieved negative emissions, which is really important as a strategy, but we can't ignore those agricultural emissions also have to decrease over time if we're going to meet our climates. So for me personally, it's a matter of recognizing that finiteness is not going to solve the entire problem of agricultural or other emissions, that we also have to be constantly thinking about emissions from agriculture as well.
Another question kind of related to that, it seems like the low-hanging fruit in soil carbon sequestration is to adopt best management practices on existing agricultural lands. But what should we be thinking about to inform our decision when we're thinking about bringing lands that have not been introduced to into ag for the purposes maybe of benefiting from these financial incentives for storing carbon in these soils?
Yeah. So I could have talked quite a bit about the policy priority of protecting existing carbon versus building new carbon. And I feel that in agriculture, the momentum has been all around investing in new carbon, as opposed to the agricultural community also being concerned about not expanding into these other lands. What we find is it's more the peatland community and the forest conservation community that are more concerned about protecting and understandably, existing soil carbon stocks and high carbon stocks like peatlands. And so, and also those tend to be associated with public interest, and they tend to be associated with government policy. And so most of the action has been around, government land zones and government enforcement of encroachment onto those lands. The issue, of course, is that we expect future food production, and I think this is a debatable number, but to increase and by 2050 potentially double compared to, I don't remember, 2010. So because of population growth and because of that subsequent food production increase, the land area in some places is going to expand, and we know it's already expanding in many places anyway. And so, the challenge is, it's a severe challenge, how to produce from existing lands without expansion into those, especially high carbon stock lands, but also not, to do so in a way that doesn't deplete the current agricultural lands. And sub-Saharan Africa is going to be in a really tough spot if they can't expand into new areas. So it's one of the bigger challenges of our times. Great questions, by the way. Thank you.
Yes, this has been a really interactive seminar, so it's been really great to see all the questions. I'm going to throw one last question at you, which I guess is something that we haven't really talked about yet. I was wondering if you have any examples of how Indigenous knowledge and Indigenous land use practices have made their way into the best management practices that we use to store carbon in the soil, and how if there's examples of scientists successfully seeking out that knowledge and rolling out those practices from Indigenous communities.
Yeah, fantastic question. I think, this has multi-layers, and we could talk about it for a long time. I think we have to remember a couple of things. Farmers inherently, are decision makers and are empowered to take decisions over their land. Part of the issue is that we have increasingly incentives from, I think especially some of the corporate, supply chains for contract farming, where farmers, buy into literally a model that involves, certain inputs, right? And those best management practices that are defined for the corporate's quality control measures. And they often subsidize farmers initially so that farmers, get over their own risk aversion and can reach that 3 to 5 year point and are able to produce, sustainably. So what those best practices are for the company aside, I think that incentive model is most at risk. It's at one end of the spectrum as to the farmers being disempowered and farmers, not having control over their practices and what may be the best Indigenous practices. At the other extreme, we have most farmers, more independently, if you can call it that, because they're still tied into market systems and, extension systems and all sorts of, information being thrown at them about what best practices are. But, they still have basically sovereignty, right, over their own soil and hopefully some decisions. And so, there's a really important, and I haven't worked in this area in a while, but an important sort of teasing apart of, what do Indigenous practices even mean anymore, right, for many farmers. So I guess I'm thinking this through as I talk about it, I think where I would conclude is that we need to be alert to safeguards for farmers who are tied into models of extension or models of incentives that promote, singular practices. And we need to be alert to, and certainly there's been so many people working on this, and I worked on this for my PhD, and even so many people who've documented Indigenous management practices that might provide opportunities. But honestly, I think it's the interbreeding of the two, and the flexibility to recognize what works best in different contexts that matters.
Thank you very much for all of your thoughtful answers to the questions. We've spanned soil science to economics and everything in between. And I think we are now about at the end of our time, and we've seemed to have exhausted all the questions. So I just want to thank you again, Lini, for kicking off the virtual gun exchange series. We're excited. This talk has been great, and we're excited for everything else that will happen this semester. And I want to also thank everyone who joined us today. And just a little plug for next week's talk. Of course, the video and the podcast of today's talk will be available shortly. It's been recorded. And we want to invite you all to join us next Friday for our next gun exchange with Jenny Stevens from Northeastern University, whose talk titled Diversifying Power, Why We Need Anti-Racist Feminist Leadership on Climate and Energy. That will be held Friday, September 8th at our noon time. And so thank you to everyone for joining us today, and we'll see you next week.
Thank you. Bye-bye.